Okay, so now we are solving some examples on node voltage methods. So let's consider a circuit, and we have a voltage source of 50 volt, 5 ohm resistance is connected, and there is 10 ohm resistance we have 40 ohm resistance connected here, and a 3 ampere source. Let's assume that the current flowing through 5 ohm resistance is denoted by IA, and the current flowing through 10 ohm resistance is IB, and the current flowing through 40 ohm resistance is denoted by IC. Okay, so this is the whole circuit, and we have to solve this circuit. So what is the objective? By solving this circuit, we have to find IA, IB, and IC. Okay, and we have also to compute the power associated with 50 volt source and the power associated with 3 ampere source. So we have these 5 things to compute, and the techniques we have to apply is the node voltage technique or node voltage method. So just recall, in the first part of this lecture we studied that the representation of the labeling of essential node is very, very important. So let's now find out how many essential nodes are there. So look at this node. Is this essential node? The answer is no. Yes, this is no. This is not essential node because only 2 circuit elements are connected. What about this node? Yes, this is essential node because 5 ohm resistance is connected, 10 ohm resistance is connected, 40 ohm resistance is connected because these 2 points are exactly the same. And similarly, this point is also the same. So we can just mark this essential node as node number 1. Now look at this interconnection. Again, as I told you in the previous example, these 4 points, these are common, these are considered to be 1 point. So we can just mark this as essential node 2. Okay, and of course you can write just a ground symbol here, 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 or anywhere. So you just mark the ground symbol. That will be of course working, just acting as the same. So there are 2 essential nodes. Again, the choice is yours. Whichever node you can just mark it as a reference node. Let's assume that we can just mark this as a reference node. That's why I can hit as ground. If you mark this as a reference node, you can mark this as ground. Okay, the next question is, how many equations do we need in order to solve this? So of course we need 1 equation because these are 2 essential nodes. A number of equations to need to solve this circuit, n e minus 1 and 2 minus 1 is 1. So number of equations needed to solve this circuit is only 1 equation. Okay, now label the voltages at the essential nodes. So let's mark this voltage as voltage V1. Okay, there is no need to mark voltage as V2 at the reference node. There is no need. So now write the equations in terms of voltage V1. Applying KCL is just in the, exactly the same, a similar argument. So applying KCL at node number 1. So we have at node 1. So we can write this as V1 minus 50 divided by 5 ohm resistance. V1 minus 50 divided by 5 ohm resistance plus V1 divided by 10. V1 divided by 10 and V1 divided by 40 is equal to, now look at this. This is a current source and the current is entering into this node, so it can be written as 3 ampere just in the right hand side of the equation. Okay? So now we have one equation, one unknown, that is V1, so we can easily solve this. So the equation can be solved. Rewriting this as 1 over 5, 1 over 10 plus 1 over 40 into V1 minus 50 divided by 5 is equal to 3. And 50 divided by 5 is 10, so we can just write here as 10. And look at here, 1 divided by 5 is 0.2, 1 divided by 10 is 0.1, and 1 divided by 40 is 0.2, I think 0.25. So you can simply write it 0.2, 0.1, sorry here 0. That was over 5, 0.2, yes, and 0.025. Okay, into V1. So adding all these 0.2, 0.1, 0.3 and 0.025, so total is equal to 0.325. Okay, now transporting this minus 10 to the right hand side, so we can write this as plus 10, and plus 10 is 3 plus 10, and of course 3 plus 10 is 13. So V1 is equal to 13 divided by 0.325. Okay, and of course doing this whole stuff, you can have 40 volt as V1. Use your calculator, and it's not a big deal, so things can be easily solved, so you can do it by yourself. Okay, so now we know that V1 is equal to 40 volt. Since V1 is known, now current IA can be computed, current IB can be computed, and current IC can be computed. And similarly, the power delivered by the sources, 50 volt source or 3 ampere currents, can be easily computed. So now look how to determine IA. So this is very now clear. I just simply remove it. So if you look at the direction of IA is equal to, let me change the pen. So IA is equal to 50 minus V1 divided by 5. Just look at the direction. So IA can be written like this: 50 minus V1 divided by 5. And V1 is 40 as we computed, so 40 divided by 5, and this is equal to 2 volt, because it's 10 divided by 5, it is 2, so it can be easily computed. Now look at IB. IB is equal to V1 divided by 10. So V1 divided by 10, and V1 is 40 divided by 10, it means that it is 4 volt. Similarly, IC is equal to, again, V1 divided by 40, and V1 is 40 divided by 40, it is equal to 1 volt. Okay, So already this part is computed. If we just consider this as part A, and if we just consider this as part B. So we are left to compute now power delivered by the source, 50 volt source, and power delivered by a 3 ampere source. So 50 volt source is producing this current IA if you look at this. Okay? So simply multiply 50 into IA, you will have the power delivered by the 50 volt source. So power delivered by 50 volt source is equal to 50 volt and current IA, and IA is 2 ampere. Since it is delivering the power, and if you just remember the sign convention, we use negative power for power delivery, so we can simply say power negative. So it is minus 100 watts. Okay, or you can simply say capital W. So this can be written as capital W also. So you can write watts and you can write W. So this power is delivering. That's why it is. We can just using the sign convention we discuss in the class. So you have to follow that. Now look at here. The 3 ampere current, and the voltage here is very important to know. That is V1, and that is equal to 40 volt. So simply 40 volt multiplied by 3 ampere. Again, it is delivering the power, so we can write this as power delivered 3 ampere current. So it is equal to minus 40 into 3. This is equal to minus 120 watt. So, gentlemen, this is another example we have solved based on the node voltage method. In part 3 of this lecture, we will solve another example just to make things more clear, and you are more familiarized with the node voltage method. So see you after that short. Thank you so much.